Okay, hello ladies and gentlemen. Let's talk about rational versus irrational numbers. So we have rational numbers. These are the nice ones. These are the ones that we like. And then we have irrational numbers. We don't really like them unless we can round them. Okay? So let's talk about rational first. One of the first things that you can tell straight off the bat, is it a fraction? Can it be a fraction? Yes, it is rational. 2, it is a whole number. And sometimes you will see whole numbers, for example, also like a perfect square. They can be repeating decimals, which means they will go on forever. So 0.333333 forever. So, okay. So those are rational numbers. Let's see what else. It can be as if it's a repeating decimal, okay? Then it can also be, so we're not going to call this 3, 4, let's call this 3b or something. They can be non-ending. Because remember, repeating decimals can go on forever and ever and ever. Now, irrational numbers, there's like one really big thing that you should know about them. They are non-repeating, so they do not repeat. And, so this is a big one, non-ending. They kind of have to be both. And then, a little side note, non-perfect squares. Okay, so one of the reasons we say it's non-repeating and non-ending, because you can have a rational number or a rational decimal that doesn't repeat. For example, 1.345. It didn't repeat, but it's still rational. And it can be non-ending, for example, like our 0.33333, which goes on and on forever, which does not end. Okay, so let's look specifically at some rational numbers. Let's see what happens. Okay, so like I said, one of the first things, it can be a fraction. For example, 2 over 3, 89 over 7, 54 over 1,283. These are all fractions. They are all rational. Okay, perfect squares. For example, the square root of 64, which is 8, thus being a whole number. Square root of 81, which is 9 and a whole number. Negative square root of 9, which gives us negative 3. And again, it's a whole number, so it kind of counts. It's not a decimal, it's a whole number. And we can have our repeating decimals, so 1.43, and if we repeat the 43, 2.9, where the 9 repeats, 0.1258, where the 1258 repeats. These are all rational numbers. It's kind of nice. We don't have to worry a whole lot about, oh, wait, is this really rational? Is this not? Okay, so also, as you guys can probably already tell, we could have things such as 0.145. This is a non-repeating, but it does end. So this is also a decimal. Just a plain decimal, we can do these two. 2.6, 4.1, 8.923. These are all wonderfully rational. And when we ask why, well, let's see, this one's rational because it's a fraction, fraction, fraction. perfect square, perfect square, perfect square. These are, because they're repeating decimals, these are terminating decimals. So those are all kinds of things that are rational. Now let's look at one of the most famous irrational. Okay, irritable, irrational, that's how I always think of it. So if on a Saturday morning when I get to sleep in, someone wakes me up for not something fun, but they wake me up at 6 a.m., I'm going to be irrational. So pi is irrational, which, and I can only remember some of the place, 3.14159, dot, dot, dot. It does not repeat, it does not end. So if I have 0.178643, dot, 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 it will not repeat and it will not end. Square root of 79 is a non-perfect square. It is irrational. Square root of 62 is irrational. It's a non-perfect square. And once you actually, if we could actually calculate them to their final decimal, it would go on for a very, very long time. So we just consider them irrational. 1.2764 dot, dot, dot. Again, irrational. It is a non-ending, non-repeating decimal. So those are really the two main differences between rational and irrational. There's nothing else to it. Come back later and we are going to talk about finding estimating irrational numbers. Enjoy your night.